Okay, this is lesson 7.3, volume of prisms and pyramids. First off, what's volume? Well, volume is the amount of space occupied by an object. And it's measured in cubic units. So for example, centimeters cubed with the 3. When you're working with a prism, to find the surface area or the volume of a prism, what we need to do is we need to find the area of the base and multiply by the height. So what's that mean? Well, the base is the shape that's extended to match the exact same face in space. That sounds kind of complicated. Let's try to simplify it. There's one shape here that if you extend it, you're matching up with the exact same face. So let's look at this shape on the right. If we picked this top rectangle as the face and extended it straight down into space, we would be matching up with another rectangle. And the question is, are we making the shape that's actually on the page? The answer is no. So this rectangle on top is not the base. The rectangle on the side, if we extended it into 3D space and match up with another rectangle, we're not creating the shape either. We are matching up with another rectangle on the other side, but it's got a different slant to it. So it's like we're extending it and flipping it, and that's not how it works. The face that we're actually talking about here is this trapezoid. Because if you extend that trapezoid into space, it's going to match with another trapezoid on the other side of the shape, and it's going to create this shape by extending 14.4 centimeters of depth. So the face is the trapezoid, and the height is 14.4. So this is our base, and this is our height. The shape on the left, the base, is actually this triangle. Because what we've done is we've extended this triangle down into space 8.9 centimeters. So our triangle is the base, and 8.9 is the height. So if we can find the area of these two base shapes, we just have to multiply by the height number, and then we get the volume. A prism is named according to the shape that its cross-sectional area. So it's named by the base. For each of the following prisms, select the correct name from the list given. So we have triangular prism, rectangular prism, and trapezoid prism. So that means the base of the first one's going to be a triangle. So if we go look at the 3 shapes, which one has a triangular base? The answer is 3. 3 has the triangular base, so this is called a triangular prism. So we would need to find the area of the triangle on top and then multiply it by the height. Rectangular prism is number 1. We'd have to find the area of any of the rectangles. It could be this front one, it could be this side one, it could be this top one, and then extend it by the other measurement. So if we pick this front one as the rectangle face, we'd be multiplying by this height. If we pick the top rectangle, we'd be multiplying by that height. And finally, trapezoid prism must be the one in the middle. We have a trapezoid face, so find the area of the trapezoid and then multiply by the height, just like this one up here. In 4 to 6, is the shaded face the cross-section area? Is it the base? Well, let's look at the first one. We have this odd shape here that's not a normal shape. The question is that the base? Well, if we extend it into 3D space, does it create the entire object? The answer is yes. For number 5, we have this rectangle on the bottom. If we extend that face up, we would create a rectangular prism. So the answer for this one is no. The correct face would be this front triangle. If we extend that deeper, we create a triangular prism. For 6, we have this shape on the back. If we extend that forward, we do create this shape. So that shape on the back is the cross-section area, is the base. In 7 and 8, which measurement gives the height of the prism? Be careful, it says height of the prism, not the height of the face or height of the base. So what that means is find the base. Our base shape is this triangle. So however far that shape is extended to match the other triangle would be the height. So in this one, the height is 12. In number 8, again we have a triangle. And that triangle is extended into space to match another triangle on the back. And it's extended by 12 centimeters. So again, we have a height of 12 centimeters. And believe it or not, these are actually the same shape. I just twisted them. For 9 and 10, find the area of the shaded face. So in number 9, we have a rectangle on the bottom. To find the area of a rectangle, we do length times width. So we've got 7 times 3, which is 21, and over centimeters squared. For number 10, we have a triangle. So it's base times height divided by 2. The base is 5, the height is 6. So 5 times 6 divided by 2. 5 times 6 is 30. Divided by 2 is 15. And since we're doing area, it's centimeters squared. So being able to find the base area, we're one step away from finding the volume of these two shapes. To do that, we just need to know the shape's heights. And we'd multiply these numbers by the heights to get the volume. All right, let's flip it over. For all prisms, volume is found by taking the area of the base and multiplying by the height. So what we're going to do is we're going to build a formula sheet. Now you have a formula sheet at the end of your lessons package, but we're going to build a formula sheet for these 4 shapes. So rectangular prism. To find the volume of the rectangular prism, we have to find the area of the base. So let's take this top rectangle as the base. That's a length times width to find the area. And then multiply by height, h, would give us our volume equation. So if we want the volume of a rectangular prism, we just do length times width times height. Triangular prism, if we want to find the volume, we have to find the area of the triangle first. So we have B and L to represent base and height. So it's base times height divided by 2 of the triangle, and then multiply by the height of the shape. So another way to write that would be base, length, height divided by 2. Trapezoidal prism. If we want to find the volume of a trapezoidal prism, we need to find the area of the trapezoid first. To find the area of a trapezoid, you might have to check your formula sheet, which I just did. The area of a trapezoid is A plus B times L. So we've got A plus B times L. And then we're going to multiply by height. And if we want, we can go check on our formula sheet. And we've got A times B, or A plus B times L times H divided by 2. Oh, I forgot to divide by 2 for the trapezoid. So we'll go add that to our equation. Divided by 2. And last one is a pyramid. If we want the area of this pyramid, this one's a little tricky. It's not just area of the base times the height. For any pyramid, it's area of the base divided by 3 times the height. Our base is a rectangle, so we've got length times width divided by 3 times height. So length, width, height divided by 3. All right, let's give these equations a shot. Let's try to find some volumes. Find the volume of each figure. So our first one is a rectangular prism. So if we go look, rectangular prism's volume is length, width, height, all multiplied. Length, width, height. So let's identify those. We've got length, width, height. So we've got 2 times 2 times 5. 2 times 2 is 4, times 5 is 20. So our volume is 20, and we're feet, and we're cubed because we're volume. Triangular prism. Triangular prism is base times length divided or times height divided by 2. Base, length, height divided by 2. So this is our height, this is our base. Uh-oh, we don't have length, so we might need to find it. Well, this side would be 25, because all 3 sides are 25. This bottom would be half of the triangle, so that'd be 12.5. We need to find L. The way we do that is Pythagorean theorem. 25 squared minus 12.5 squared would equal L squared. I'm going to use my calculator. 25 squared minus 12.5 squared is 468.75, and to find L, we would square root. And we get 21.65. So a little bit of work with Pythagorean theorem first, and now we know L. So we've got 25 times 21.65 times 70 divided by 2. And that's how we find our volume. That one's pretty complicated. I think if I gave you that one on a test, I'd give you the height. 25 times 21.65 times 70 equals, divided by 2, we end up with 18,943.75. And we're in centimeters cubed. All right, let's end with one that's a little bit easier. We've got our pyramid. The volume of the pyramid is length, width, height divided by 3. So we've got length, width, height. Perfect, no Pythagorean theorem. 30 times 30 times 36 divided by 3. 30 times 30 times 36 divided by 3, 10,800. And we're in yards cubed. So there we have it. That's how we can use our formulas to calculate the volume of some regular shapes. And if the shape's irregular, you just find the area of the base and multiply by the height. That's it for lesson 7.3. I'll see you next time for lesson 7.4.